Hello everyone, and welcome to Moxa's webinar, How to Integrate Network Solutions for Intelligent Transportation. I'm Martin McHugh, and I'll be your moderator today. If you have any questions at any time during the webinar, please use the questions pane by simply typing in your question and clicking send. At the end of the presentation, we'll do a Q&A session and take as many questions as we have time for. We will follow up with any unanswered questions after the webinar. Okay, let's get started. We'll have a 30 to 40 minute presentation with 10 to 15 minutes of Q&A. Today's presenter is Jay Mercado. Jay is a product marketing specialist for Moxa, focusing on solution integration. Previously, he was a tech support engineer for our data acquisition and control, embedded systems, and video networking product lines. Jay possesses a wealth of knowledge when it comes to specifying and deploying networking solutions and systems. And with that, I'll hand it over to Jay.
All right, everyone. Hopefully you guys are having a good day. I'm going to be basically going over just ITS in general, the introductions, what we've seen, industry trends, needs and requirements, typically what we look for in an ITS application, and lastly, reliability, security, integration. It's probably what we all kind of look forward to as the technology increases. So intelligent transportation systems, what is it? My definition is just basically embodiment of layers of communications that provide real-time feedback of vehicle-to-vehicle and vehicle-to-infrastructure communications. Essentially, what we see is that there's a big scope of this new technology where we're able to get all the information pushed back either to us locally on our phones, it goes back to a central location, but more or less just the integration of these communications. In Wikipedia, you can see ITS as systems in which information and communication technologies are applied in the field of road transport, including infrastructure, vehicles, and users, and in traffic management and mobility management, as well as for interfaces with other modes of transport. In several applications, there's already ITS has done several things that have kind of more or less helped this, the environment we live in, especially when we're driving. Adding a law enforcement speed camera, it was able to decrease the total target crashes from 44 to 54%. Injury crashes to 28 to 48, and property from 46 to 56. And another thing is in New York State, we also have the Ports Authority to reduce traffic by, getting vehicle probe data available to those people driving on the I-95. There definitely, what you see here is that overall the scope of ITS, it's all about efficiency. It's all about understanding what's going on in the highways, in the intersections. And it's not only for the traffic centers to see that, but also the users, the commuters, all of us who's involved in this kind of more or less transportation environment. What we see in graphs, and I got this from the its.government, is that there's one increasing demand for phones. Smartphones, new iPhone just came out. Samsung is releasing. There's a large demand for these because now there's data being used. A lot of users do social media. Definitely, this has impacted the growth in sales and impacted the use of what the sales have actually, the data is actually used for. What you also see is that with the growth of that technology, now development of apps, development of communications, Google Maps, Waze, all those use these types of information that come from, traffic lights, come from the cameras that come by. It allows us to get all that information and put it somewhere that we can all utilize. If you're a Waze fan or a Google Maps fan, you'll see that happening. You'll get real-time data telling you when your maps change or when's a good route to take. And along with those demands is you'll see that a lot of transportation or Department of Transportations are trying to figure out, what can we do with this data? How can we make this useful? So you'll see that there's a lot of traffic conditions, weather conditions, even gas prices are now being aggregated into a system. It's all being converged into one whole system to provide that information. We typically, rather than just hearing it from someone, we'd rather just get the information and understand logically how we're going to map and plan out our day. And even do anything for that matter as far as gas prices. And we all know how that is. So what we'll see here is the original infrastructure for the ITS environment is that you just see the traffic lights. They probably go off of a sensor that times it based on a given amount of time. Now what we see in traffic lights is they use the cameras to do industrial video analytics so that when a car actually approaches, it's more efficient to setting off the red lights and the green lights. You also see that in buses, in trains, the daily metro buses, you'll see that they're able to provide you real-time feedback of when you're actually going to get that bus to come at that stop. You'll see on your daily commute on the freeway, you'll see how long it takes to get from one freeway to another. And that's all just basically that convergence, just getting the different aspects of the transportation environment and pulling it all together to give you that information. Now what I'd like to specify is for those consultant system integrators is that there's actually different parts of the Department of Transportation. There's a city Department of Transportation which typically focuses on traffic signals and street intersection. And the County Department of Transportation works on inner-city communication ties, traffic signals, street intersection, even schools. And then what you'll see on the State Department of Transportation is that there's freeways, weather stations, tollways, more specific to the state and not specific to the location. And this is pretty key when you're getting involved in these applications because you want to know, how all these systems interconnect. And when we talk about the Department of Transportation and we talk about ITS, it's not just one huge infrastructure that it goes to. Several Department of Transportations will have their own systems, will have their own devices, and how they're going to intercommunicate with each other. And that doesn't mean one state will work with the other state. It's just you have to know to differentiate one or the other. And as I mentioned before, these are just examples of intelligent transportation systems. You'll see the buckle up signs. Those push just standard ASCII characters to let us know if there's buckling up, someone's been abducted, or any of that sort. You'll see the cameras that are out on the freeway, which just not only just see the freeway for traffic, but it actually does it for accidents as well. You'll see the red lights. We all don't like the speeding tickets or anything like that, but those cameras do catch your license plates and your faces when you're driving along. And at the bottom right, you'll see all those systems are integrated together to one control room and manage the daily commute. So let's start off with the interactive poll questions. How have intelligent transportation systems assisted you in your daily commute? I know for me, when I typically drive to work, even though it's only 4 miles, I still use my Waze apps to either tell me if I should take another street or do another route just to save a minute or two. My commute to LA even, changing one freeway can save 10 minutes. So I'd like to know what you guys have used, maybe Waze, maybe Google Maps, maybe you use SigAlert. You don't even have to have that real time, but you really want to know, your route. How about the weather stations, knowing what you'd like to do? So essentially, I like to hear your feedback, and that way we can figure out, what a good majority of us are. And I'll have Marty here post up the what we've seen, and it looks like you guys also use Google Maps and Waze. a good portion of you also said that it efficiently plans your route, which is good. That's essentially the purpose. Not only is it supposed to help us with our commute, but there are other aspects to ITS. I recently went to the ITS World Congress, and traffic was one of them, but safety is another, trying to figure out how we're going to get our cars to make sure we don't crash against each other, or newer technology for connected vehicles. It's definitely gone to a different route and has definitely changed over from what it was originally. Now, the trends in transportation. So, as I mentioned, we have the safety focus, reduce fatality rates, reduce congestion, interest in transit, environmental awareness. We kind of now we're getting into electric vehicles, the green vehicles, to make sure that we don't have a lot of carbon footprint. Emphasis on performance and measurement. We typically use this to understand how fast a person will go down a specific freeway, just to make sure that everything is efficient and effective. Now, as those requests are made, the increase in technology will also occur. Wireless technology has skyrocketed. And thinking about cellular communications with larger data bandwidth will, have more use for those remote locations. You have a stronger consumer market. Think about, as I mentioned earlier, the mobile applications. The fast pace for innovation. Apps are made on a daily basis. Even kids who can just do a simple YouTube can actually make an app. But think about the transportation side of things. There's always going to be a need to make these applications exist and a need to figure out a way to make it simple and simple for users to adapt to. And the expectation for information. What do we want? We want to know all the data, if there's any accidents, if there's any traffic, and so forth. Another piece of the ITS, which is actually gaining momentum, is the connected vehicles. Even though it seems a stretch, there are a lot of organizations that are working to make this happen. It's basically the innovating of different communications among vehicles and infrastructure. There's applications where buses actually record video, and if a police car comes by it, they're able to stream the video feed coming out of that bus. It's just more or less having a way to have the intercommunication with not only the vehicle-to-vehicle, but also the infrastructure. These devices typically include the embedded devices that will data log and gather the information. It'll also include some GPS device, whether or not the embedded devices will have it. It will either have that or a cellular device to gather all that data and push it somewhere. And then vehicle communication devices, such as sensors, motor, anything that related to your vehicles that you can see so that you can gather all this information and make use of it. So moving forward, I'm going to go to the needs and requirements. During my research, I've noticed that there are a few key topics that are actually expressed with going with ITS. With the idea of hackers and being able to penetrate networks and probably severely crash a network, security is one of the biggest concerns. Talking to some of the Department of Transportation is the data bandwidth. Right now, some of them are running on 100 megabit speeds, and a lot of DOTs are currently migrating or have already migrated to gigabit speeds. Now they're also even going 10 gigabit speeds. So the more we, the more we envelop ourselves with this technology, the more data we're going to want to have. And essentially that's where we're going to have to have more data bandwidth on those pipelines coming back to the central location. Now, reliability is a big thing in the industry where if a device crashes, it can take up to hours or days to get your system back and running. Now, if it does that, imagine your commute changing. Imagine if your traffic light doesn't work. Imagine if you can't tell how long it's going to take to get to your location. As we do grow into this technology, we'll realize that reliability will be key because we don't want to have any downtime. We don't want to have any issues communicating with those devices out on the field. And lastly is the integration. If we think about integration, we think about there are legacy devices in those cabinets out on the field. There's serial controllers out there that probably still use RS-232 communications, 485 or 422 communications. And the next question is, how are we going to route that back? We have existing sites that already have this, and how do we expect to pull all that information back without having to make a complete retrofit of that whole environment? There's definitely technologies, and I'll kind of discuss that with you guys as we proceed on to this presentation. So, understanding the process, and here I'll be going over the concerns that I just mentioned and why it is, and basically the implementation. So for big data bandwidth, the lower data bandwidth restricts flow of data through a network. And with the development of IP video, you'll see that there's a big demand for gigabit networks because we want to stream all that video data across. It's not only on the freeways anymore, it's not only on the side street, but just everywhere that you can get a feed to make that information readily available. In this particular case, now you have managed and unmanaged working together to make this big data constraints using gigaports. Next thing is security. So security issues can always, like I said, arise, whether a hacker outside or even potential internally. You'll realize that even though someone outside doesn't can't penetrate your building. If someone were inside, would you change your configurations to a switch or change your configurations to a device server, then you'll basically have crippled your network already. So security has definitely impacted the way we design our networks, because we have to make sure, one, no one externally can get into it, and two, the proper privileges internally will work as well. So the government is definitely placing specific requirements on these network devices to prevent breaches from occurring, such as ISA 99. There are other certifications that are going to basically be used and have every manufacturer be applicable to make sure that when they use these devices out on the field, it's a secured network. Now, reliability. I talk about reliability with not just more or less the devices being able to stand there, but redundancy. There's chains, there's rings, different manufacturers have their own form of redundancy. And having a redundant network definitely strengthens your network to make sure that if a switch were to go down, you have a back route. You'd be surprised in some Department of Transportation, they don't really have this yet. They're kind of, oh, they didn't know it existed. And so you're running with a single point of failure, and there's no redundancy. So being able to introduce that value, you'll see that having this redundant network makes sure that the growth in the ITS will be secure, you'll have more reliable communications, and you'll definitely decrease the downtime of being able to bring your system back up. Lastly is integration. As I mentioned earlier, now you have pre-existing sites that you don't want to pull out, all your DC cable or Ethernet cables. So especially with the way budgets are being handled through the states, you have financial constraints on what you can do with certain installations. That shouldn't be a reason to prevent you from integrating with ITS, because there is technologies that help you still utilize that same wires and lines to use newer technology at the same time. And big data, that's definitely every aspect of ITS, is getting everything that you can get, analytics, and trying to be able to figure out how your daily lifestyle of the ITS can benefit everyone, not only you but as well as the DOTs. Now, what I've seen is that there are some infrastructure requirements. Serial signal controllers are still widely used, and some of those serial signal controllers still use serial communications. In those aspects, you can get a device server that can kind of help you get that communications over to Ethernet if you're already migrating into it. But there are some serial signal controllers that also use Ethernet, interestingly enough. So it helps you still utilize and gather that data with newer technology. The NTC IP protocol for newer Ethernet communications is basically a standard that is used to make sure that all the Ethernet controllers, all the devices are interoperable with each other. You're not dealing with a very vendor-specific protocol. Now you have interoperability with other vendors. And some technologies will use copper wiring, and the reason why I bring copper wiring is because there's some serial communications that occur, and in some cases you don't want to rip out two wires, and if you want to communicate Ethernet communications, you can actually use DSL extenders, meaning they'll talk DSL over that copper wiring and bring out Ethernet communications on both sides. The caveat to that is there is some, depending on how long the copper wire is, you're going to get some speed bandwidth that's going to be dropped down only because of that. But it does allow you to get that intercommunication. Again, redundancy is important, and it can make a difference with how your application is made. As I said, the ITS environment there's an increasing demand for the cameras. A lot of preferences are for the PTZ, but 90% of the time they're stationary. So there are a lot of stationary applications that you still use fixed cameras just meant to view and monitor. And as the PTZ technology develops, more will come. Right now, I would say that a lot of camera vendors will have their own requirement for power. More specifically, DC and Ethernet cable is okay if you have that running, but a lot of the requirement for ITS is PoE. There's high power PoE, which isn't a standard yet. So different vendors will have different versions of their own high power PoE. even though they mention it's 60 watts, some vendors will put two 30-watt modules in there just to support that 60, or some of them will have to require devices actually outputting 60 watts. That's where you're put in a gray area where you really want to focus on, okay, if I want to put on a camera, one, will I go with something that's not a standard, or can I live with that and probably migrate into something later? But keep that in mind when you're dealing with PoE and cameras, because the high-end power PoEs there's no standard yet. The standard PoE, the 30-watt, 802, the AT and AF, then that's kind of more or less where the lower end power is, and that's pretty much basic for most cameras out there. One thing that I did notice is when you're putting these cameras outside on the field is there's a lot of shock and vibration. There's different application, and you really want to focus on those certifications, because even though you're getting a camera at a very low price range, you want to make sure that the camera will actually last. In some cases, you have a camera fall apart because of it's unable to take those vibrations. So I would say make sure that you focus on the certifications that apply to the application so that you don't have a faulty camera within 6 months. You want to make that last lifespan of what you expect it to be, 5 to 10 years. Another application is where there's still, users still using analog cameras, and for you to use the analog cameras, you can't just rip it off and drop an Ethernet cable in a PoE or Ethernet IP camera, because you still have existing devices. Most of the times they would drop an encoder. Previous encoders had fans, but now encoders will have a fanless requirement for applications so that you don't have any issues with temperature and affecting failure because of the fan's mechanical issues. Lastly, in regard to this, is that the traditional was MPEG-2. They're all migrating to MPEG-4 and as well as H.264. Usually now a lot of ideal designers would go with the H.264 only because it's a better compression and you can move that data in a shorter bandwidth. So based on what I've said, I'd like to reach out to you guys and see, out of the 4 key issues, which do you think is the most important? Do you think it's data? Do you think it's security? Do you think it's reliability or integration? I know that this question can probably range depending on your job roles and description, because you're at the Department of Transportation and security is a big key issue for you. You may be a system integrator, and now you're like stuck with trying to figure out how you're going to get all this data with legacy and newer technology. How would you integrate and use all these data to combine together? Let's say, for example, now you're thinking about deploying switches, and you're thinking about, should I put 100 megabits per second bandwidth and leave myself at the technology, or start upgrading to 10 gigs so that you're more you are more available for the future as they kind of progress. And it looks like here from our polls that it's big data and integration. And I actually, interestingly enough, that's what I got as well from the ITS World Congress and several of the workshops that I've joined. I've seen that, what are we going to do with this much data, and how are we going to move that at an efficient time frame without having any bottlenecks? Integration was always a big issue, because it's like, there's all these devices deployed, what am I going to do? Even for those remote devices that are deployed, one question is, how can I get my return on investment on that? How am I going to know that devices are actually working? I'm getting all the data that I can get. And that's all about integrating and putting all that system back together. So what I'm going to talk about next is more or less solutions and what you can do to integrate and put these devices together as it relates to ITS, reliability, security, and integration. So connecting the dots, how to integrate your system. Wireless. There are several applications that we use wireless. I know there's lots of applications that use DSRC, Wi-Fi technology, ABGNN, and in some cases the cellular technology. And what you'll see these is that in some applications that you see with the Department of Transportation is that some message boards actually just use Wi-Fi or even cellular to push all those serial and ASCII strings together. So getting a reputable Wi-Fi or cellular module device will actually just work for that applications. It's usually used for those remote applications that you want to deploy, probably push data back, whether it's streaming video, and it's possible. You just have to understand the requirements of that. And then data acquisition. So what I've seen is data acquisition, we have digital inputs and outputs that are used in several applications. Traffic management. As I mentioned earlier, traffic lights are sometimes set on timers, and school zone signs. One application that I've actually seen for these data acquisition is being able to mirror some inputs and outputs to configure how the ramps, freeway ramps, will work with each other. In some cases, you'll have one ramp trigger another ramp to go on and off. In kind of emergency response applications, you have a fire truck coming down the freeway or an intersection. You want to make sure that those cabinets are able to pick up that fire truck coming along that freeway and change those signs immediately without having an operator doing it as it occurs. DSL extenders. This has been a growing demand, but no one really, I would say, let me take a step back. It's a good product to use, but no one's really aware of it. And I would say it should increase the demand shortly because of the retrofit applications. You have long-range communications without having to rip out all your lines. You DSL extenders that will allow you to communicate on both sides, but you have your Ethernet communications. So essentially, that allows you for room to do retrofit applications at good, decent speed. If you're transferring signal data, you're transferring some about 50 megabits per second. It's not ideal, but it's enough to get that data if you need it without doing a pulling out the whole system. Now, media converters. As we do progress into the newer technology, let's say, for example, you don't want to use copper lines, and as you said earlier, the big data, media converters allow that. You can have Ethernet communications and go through a fiber backbone. You can make sure that the signal fidelity doesn't get dropped. You can also, going with that is if you have the switches, you want to put fiber, so you want to have a higher data throughput. Again, the applications here is loop control, vehicle detection, signal detection, and occupancy meters. Because they're very simple applications that allow you to gather that data without having to put something very complex. Embedded computers. Now there are embedded computers that basically is very, very small scale. Some of them can be a rack mount scale, but you'll get a base operating system that allows you to aggregate all this data. Instead of having all your locations pushed back all through the Ethernet backbone and put it to your central server, what you can do is you can have embedded computers in some of those sites that will basically create metadata. It'll aggregate all that information and then have the embedded computer push back. That can help, one, either reduce the amount of data bandwidth you have pushing back down to your central network, and it can also help you organize that information without having so much streaming down the pipeline. Lastly, Ethernet switches and routers. How are we going to communicate without these devices, right? You have managed and unmanaged switches to aggregate to a central location. Now, with routers, you're definitely going to see that there's going to be a good trend. When you have switches that are embedded with routers, you have the ability to have multiple VLANs, layer 3 routing. You're able to have something in a small form factor that you can just basically be able to implement on your sites. With routers, as I mentioned earlier, is that there's external and internal hackers. Let's say not say hackers, basically something that can corrupt your communications. For routers, you can have your standard firewalls, which will prevent users from coming in and accessing your network. But there's also bridging or transparent firewalls that you can input in your system to prevent communications. Let's say, for example, you have devices out on the field, controllers that use Modbus or use some sort of protocol. You can have the bridge transparency to filter out specific protocols so they don't get pushed up on your Ethernet backbone, or you don't have someone writing into your device and making changes because someone at the central location doesn't know what he's doing. You can filter this using that, and that's what I mean. You have different ways of having security and using routers, because you have externally someone can corrupt your data, but internally someone could ruin your whole system, and you won't have anything to help you out and resolve and mitigate that issue because you don't know where it came from. So some of our Department of Transportation applications, as I mentioned, you'll see here that there's redundancy. You know, you have redundant networks to allow the video communications and serial communications to pass. You'll definitely run into 10 gig Ethernet. That in this case, right now, it's in the central location. But as I said, technology increases. You'll see those 10 gig Ethernets pushed back down even to the remote sites if they need it, depending on the devices they put. You have the gigabit fiber for reliable communications. You don't have anything to ruin the fidelity of the communications. And then you have your serial communication. So if you need to push back those old legacy devices, you can over Ethernet. And the idea here is to have rings and chains. A lot of manufacturers will develop this technology. It varies depending on the manufacturer, but the whole concept is redundancy. If one device fails, it's going to have a back route to get back to the central location. And that's one. You can have multiple layers of redundancy. So it can get intricate, but it's definitely the complexity that helps you make sure you have a secure network. Another one is the Caldecott tunnel. So you'll see here that the idea of this is being able to not only use that ring topology, you know, you have that in several devices, but being able to manage that through some NMS applications. Being able to view that at a real time, you're able to make adjustments to either devices on the fly, or you can even bring an engineer down there to figure out an issue if that so be the case. You can push all this data back, and now with NMS technology, it's not only related to, you know, just having your switches, but you can go out to other IP devices, of course, that support SNMP, and you can reach out to cameras, you can reach out to, you know, your encoders, you can reach out to your device server. So you'll definitely have a real-time understanding on the back end of managing your network and being able to get that information so that if anything occurs, you'll know it at real time. Another application is you'll see some stoplights, and they've been able to use wireless access points to have intercommunication. So you don't have to run lines under the ground or over because you want to get more communications. With Wi-Fi technology increasing, there's definitely some more throughput being produced by the devices to put you back into where you need. And let's say, for example, you think, well, what if the Wi-Fi device, you know, gets hacked or something were to infringe it? It's essentially why you would drop, you know, another router right after that to secure you. So the Wi-Fi can get severed, but now your devices in that location, it can still be running active, and by the time you can be able to get your system back up and running. So the next piece is essentially what a lot of users, I guess, would like to haven't really thought about, and it's basically understanding the network lifecycle. If you think about the Department of Transportation, you think about the system integrators, you have your consultants, you have everything. Once the project is deployed, that's basically it. But as we grow into the ITS environment, we're going to really have to focus on being able to manage, maintain, and operate our network efficiently without, you know, using too much resources. So installation is in this part. I want to discuss developing systems that can easily integrate it easily. And what I mean by that is manufacturers will allow you to provide tools to configure your devices, you know, pretty fast. And what I mean by that is you can do mass configurations rather than having one technician or one engineer connecting one computer to that one device to program it. There are technologies out there now that will allow you to aggregate 20, 100 switches all in line, even though they have the same IP address. You'll have this one application that's going to be able to mass configure and put the IP address on all of those devices. You can have applications that will also set your VLANs all in one shot. It's good to know this because now instead of having your customer you slowly do one by one, you cut their time and resources of implementation by half or even more than that because of the ability to do mass configuration. The next is the operation and management. The reason why this is important, as I mentioned earlier, you have your network management software. You have your ability to see these networks. Now, the next is how are we going to make value of that information? We need to receive traps. We need to understand how we can do that, and then at the same time, if an issue occurs, can we push something back to the device so that you can reconfigure it on the fly? And having network management software allows you to do that. You're able to visually see your network and be able to adjust accordingly without having to move too many mountains to get that done. You don't have to get someone on site to figure out what's going on. You'll definitely see it through that. But let's say, for example, now you have your NMS application and you can't figure out what's wrong. You have this alarm that's going on. What do you do next? How would you typically resolve this issue? In some cases, you'll have someone definitely go out on site and try to spend hours trying to figure out what's wrong. There are tools out there, Wireshark for example, and there's other tools that will allow you to actually digest that issue and figure out what's going on. You can compare your configuration files. You can compare the events that occur. Some NMS applications actually track the events, and from there you're able to manage and basically understand and analyze that data and figure out what happened, what changes were done to those remote devices that caused this issue. So you don't have to spend that time pulling out doing trial and error tests on the field when having, spending an engineer to go out at 2 or 3 in the morning just to try to figure it out without an idea of what happened to the device and the network. So I like to end this meeting off with just a few takeaways. I know it's a large piece of a lot of data that you probably got, from the ITS and basically how to integrate. And there's definitely the ITS market will continue to develop in means of gathering data and provide information to the public. Before, it was just more into the central side and figure out, okay, where are there accidents? How can we make things efficient for emergency responders? Now, people are able to use that information and make their choices in running their homes more efficiently, making sure accidents don't occur, and so forth. Now, due to the technology in ITS, we will always have the consideration for security and reliability. It's always an ongoing trend, depending on terrorists, anything. These issues will always come up, and there will always be certifications, always specifications and requirements that will always be there. It's always good to know what those are so that you can follow and comply to those standards without having to worry about putting a device, inspecting out a device that will not even be applicable to their network. There are products that do exist that allow the convergence. As I mentioned before, Ethernet fiber communications will be and Wi-Fi will be the growing trend over the communications. And products do exist to allow you to go along that backplane. You can, use device servers. You can use you can use Wi-Fi. You can use other data converters that allow you to put that information back. So the technology exists. It's just more or less trying to figure out who has it and what can get that readily available to you. And as the technological convergence continues to develop, there's a need for efficient installation, operation, maintenance, and diagnostics on all the devices connected. As I mentioned in the previous slide, we're going to have to start realizing that these networks are going to get exponentially big because of the amount of devices that we're going to put on there and how we're going to get that data back. So it's always keep in mind how would you do that efficiently, because at the end of the day, it's the amount of resources that you have either on your side or someone else's side to figure out what's going on if there are any issues for implementing. And with that, I'd like to say thank you. I hope that this webinar has been informative to you guys, and I'll leave it up to Marty.
Great, thanks Jay. Okay, now we're going to open it up for the Q&A section of our presentation. If you haven't already, please fill out a question in the questions pane. And it looks like, Jay, we have our first question from Joe. Joe wants to know what is recommended to stream live video over cellular. So maybe provide a little more insight into that.
Okay, that's actually a really good question, Joe. When we're talking about streaming live video over cellular, and cellular as the technology increases, there's always that data limitation. You're struggling to comply with having to have good visual video streams, and you're stuck with that cap of either 3G or 2G communications. What I've seen in the past is that ideally you like to get 4G or 4G LTE technology, but there have been some users that have used 3G. The caveat, however, is you'd have to drop the resolution probably to a 480, which is also a kind of a ITS standard. A CIF CIF is basically the size that they typically use, and they would use 10 to 15 frames per second. The typical bit rate would be, if you'd like to know, is probably 200 kilobits per second. And if you think about that, that should be enough bandwidth using 3G communications. I would definitely advise to test it first before you provide it as a solution, just in case that the cellular communications might cause an issue. Because even though your device supports 3G or your provider supports 3G, you have to figure out if the cell tower that's allowing you that access allows you that throughput.
Great, thanks, Jay. Definitely interesting topic in trying to stream video over cellular, so I appreciate your insight there. The next question comes from Ed. Ed asks, would it be beneficial to use extended temperature models compared to standard temperature models in an ITS environment? So some additional insight there from you as well.
Yes, Ed. Actually, you know, a lot of manufacturers have the options to have both versions, or one manufacturer will just have one of the temperature models. And the key benefit to actually just using extended temperature model is it's not a requirement, but you'll see that there are NEMA enclosures out there that will either have a fan or no fans. And if you put a device that is a standard temperature, it's not only just based for the environment outside, but think about the temperature that's being created inside that NEMA cabinet. If you don't have a fan, the standard temperature model could fail. If you do have a fan for that standard temperature model, if the fan fails, then you're back to square one. You're still having the issue of having to worry about reliability. Extended temperatures have been more or less growing in the environment because they know that whether or not you have your environmental changes or the different spectrums of -40 or whatever temperature that you really need, it's always key to keep that in mind when you're designing these. It's not a requirement, but it's definitely good to have, especially when you don't want to worry about when you have reliability as one of the topics of your discussion.
Awesome. Thank you, Jay, for that. This next question comes from Augustine. Augustine asks, is NTCIP still an important standard? So I don't know what information you might have on that, but maybe you can share the research that you've done and the insight that you do have, Jay.
NTCIP, it is still an important standard. It's also still, I mean, you can get more details about NTCP out on their website. It's also in this presentation, but it is a standard to make sure that the communications for legacy serial devices or legacy controllers allows interoperability. Now, this is a requirement because we don't know what's already out on the field, and that will make sure that it's kind of focused on a standard that exists. And a lot of what I've seen in the past is a lot of Department of Transportation have actually requested this. Does your device support NTCIP? Can we go with this? And typically, it's usually the demand that I've seen. So I would say based on the research that I've done, it is pretty important, and just keep that in mind when you're talking or discussing your system solutions.
Great. Thanks so much, Jay. The next question comes from Scott. Scott would like to know, what is a better solution for ITS, multicast video or broadcast video? So share your thoughts there.
Sure. Depending on the application, let's say, for example, you have a transportation and you're dealing with a bus or rail. In some cases, they use multicast communications. If you're going over cellular, multicast wouldn't be an option. I would suggest that if you're going over cellular and you're streaming it over cellular, you'd use unicast. That way, you have that one point direction. That video is not getting dispersed anywhere else. So it really varies on the application, and you can, depending on where the end application's requirement is also expecting. Think about some of the third-party video management software. Some of them will require either multicast or unicast. Some of them will support both. That is also effective by your network infrastructure. How much data do you want to pass? You have multicast, which is going to be multiple users, multiple streams, and unicast, you're going to have one. So I would say focus on what the requirement is of the application, and then make your educated guess if you want to go with multicast or unicast.
Great. Thank you again, Jay. We're going to allow a few more seconds for some more questions to come in. And with that, I have another question here from Anne. Anne asks, if I wanted to replace a non-PoE device with a PoE device, what can I do with the existing lines? So take it away, Jay.
Okay, and I'm going to assume when you're talking about non-PoE device and existing lines, you're probably talking about DC lines going out to your end device, and probably Ethernet lines that are going to those devices. And let's say, like I said, you don't want to rip those devices out, and you just want to keep that, but still be able to implement this new technology. Technology does exist, like PoE injectors or PoE splitters. PoE injector, for that sense, would be able to allow you to get that DC signal and the Ethernet signal and turn it into a PoE signal to go to your IP device, your PoE IP device. If you want to do the alternative to that, it's called the splitter. You can run a PoE line, which will then split that line into your DC and your Ethernet to power up a legacy device.
Great. Thanks, Jay. Looks like we have one last question here from Michael. Just came in. Michael asks, is the purpose of the AC power input for cabinets for non-industrial or commercial grade products? Something asked that again. Is the purpose of the AC power input for cabinets for non-industrial commercial grade products?
I think what you're asking is, like, what's the purpose of the AC cable in those cabinets? Typically, running DC lines over cabinets, you're going to get over copper. The DC voltage will start dropping. Essentially, what these cabinets will have is AC because you're going to have the voltage continuous, and you're going to also have either these cabinets will have rack mount devices which will pull lots of data. So depending on your cabinet, usually most cases it's going to be AC because they want to be able to, one, not only power some AC devices, but you have DIN rails that are also used that in some devices use DC power. So it gives you the flexibility to have both rather than just having a DC line out to that cabinet.
Great. Thank you, Jay. So with that, we'll come to an end here of the presentation. So I'd like to thank Jay. Thank you to everyone for your interest and participation. Also, everyone will be receiving a follow-up email with both the recording and presentation slide deck. Lastly, please take a minute before logging off to fill out our survey, as we really value your input and feedback. Thanks again for tuning in, and have a great rest of the week. Bye now.